Hello guys, welcome back. So here we have another question on network theory from GATE EE 2021. So for the network shown, the equivalent Thevenin voltage and Thevenin impedance as seen across terminals AB is 10 volt in series with 12 ohm and 65 volt with 15 ohm, 50 volt 2 ohm, 35 volt 2 ohm. So and this is the circuit, and from the options only you can see, first if you just find the voltage, you have all four are different options. When compared to the impedance, you have 2 ohm 2 ohm common. So if you just find the open circuit voltage, then you will be able to guess the answer correctly. And after that, you can just find the impedance for verification. Okay. So let us try to find the voltage. Okay. So here, if you see, in all previous questions, we used source transformation and all, right? But here you cannot use source transformation because the current in this arm is being used as a controlled, or rather the controlling quantity for this voltage source. In that case, when you write it in this form, you actually lose the information on this I1 because this I1 is not equal to this I1, right? So you should not use source transformation in these cases. And similarly, not just source transformation, if you have a network here, you have some voltage control voltage source or any control source here, and this whatever the controlling parameter, right? So I'll call it V1 or I1. If it is part of this network, right, V1 and I1 is part of this network, then you should not take the Thevenin or Norton equivalent of this and then substitute it like this. Why? Because you are again losing the information of V1 and I1, right? So you're not supposed to do source transformation or Thevenin equivalence in this case, in these particular cases. So then how we'll solve it? So we need to find VOC here. So if you see, the current 5 ampere is coming here. Where will this flow? Can this flow here, 5 ampere? Because this is open circuit. So current in this arm is 0 ampere. So all the 5 ampere should flow here. So then what can you say about this voltage? I'll call it V1. So my V1 is equal to 10 ohm into 5 ampere, which is equal to 50 volt. Now you also know the value of I1. Your I1 is nothing but 5 ampere. So your 3I1 is 15 volt, right? This is a current control voltage source. So it gives the value of voltage. So your VOC is nothing but your V1 plus 3I1 plus, in this there is no current. So there is no voltage drop across this resistor. So 0. So VOC is 50 plus 15, which is 65 volt. So if you go back to the question, option B will be the right answer. So let us also go ahead and find the impedance, right? Maybe in some cases in future questions, they give all differently. Then we will not, then sometimes finding the impedance may be easier. Or if the voltage also they give two of them same, then you have to automatically find both of them to arrive at the answer, right? So now let us find the impedance, Thevenin impedance. So for Thevenin impedance, what we have to do first, we have to short the voltage sources and we have to open circuit the current sources, right? And what current sources and voltage sources are we talking about? Independent, right? So independent sources are removed. Removed as in, for current source, it is replaced with the open circuit. For voltage source, if it is there, it should be replaced with the short circuit, okay? So now we only have this part of the circuit. Now this has a, so I'll just write it here. So this voltage source is short, current source is open. And second, so the remaining circuit, when you observe, this has a controlled source. So then just by folding the elements, you will not be able to arrive at it. If it is only resistor, what you can do, you can just combine in resistors in parallel and keep on simplifying until you arrive at the one single resistor. So that is not possible here. So here you have a control source. Then what you have to do, you have to connect 1 volt voltage source or 1 ampere current source across whatever you want to find the Thevenin equivalent. And if it is a voltage source, what you have to do, your Z Thevenin is nothing but 1 by I. I is the current drawn from the voltage source. If it is a current source, what you have to do, your Z Thevenin is nothing but it is just equal to V. So in this case, which one is easier, do you think? Since the controlling quantity is I1, if you just connect a 1 ampere current source, your I1 will be equal to 1. So it will be easier to solve it. So here we'll proceed by connecting a 1 ampere current source. So this is 1 ampere. Now you need to find V, voltage across this. So 3I1 is nothing but 3 volt, right? So can we find the voltage? It is the voltage drop across this resistor, which is 10 into 1 plus this, the terminal is increasing in this direction. So it is plus 3 volt plus 2 into whatever the current is flowing. So 2 into 1. So it is 10 plus 3 plus 2, which is 15. And your Z is equal to V, which is equal to 15 ohm. So why are we saying this Z is equal to V? Because whenever you have some impedance ZTH, if you connect a 1 volt voltage source across this, the current will be 1 volt by ZTH, right? So from ZTH, if you want, from I, if you want ZTH, your ZTH will be equal to 1 volt by I. That is what is this equation. Similarly, if you have ZTH and you connect a 1 ampere current source, your voltage will be equal to ZTH into 1 ampere, right? That is what is this equation. So ZTH is V by 1 ampere. So V by 1, we just write it as V. So all the V is in volts, V by 1 ampere will be in ohms. So we arrive at 15 ohms. So our answer is option B, 65 volt and 15 ohms.